Alright. So let's do some simple calculations here. Let's calculate the momentum, the speed, and the kinetic energy of an electron that has a wavelength of 0.30 nanometers. So what equation do we need here? We're given lambda is 0.30 nanometers. How do we calculate P? P is h over lambda. Right? So h is 6.626 times 10 to the negative 34 joule seconds divided by lambda, which is 0.30 times 10 to the negative 9 meters. And that's how much? .626 times 10 to the negative 34 divided by 0.3 times 10 to the negative 9. So what you're getting? 2.2 times 10 to the negative 24? Okay. So 2.2 times 10 to the negative 24. What would be the unit for momentum? Momentum is mass times speed, so kilograms times meters per second, right? And see how you come up with that unit. What's a joule? A joule is kilogram meter squared per second squared, so that's a joule multiplied by seconds over meter. So meters cancel, so that leaves you 1 meter on the numerator, and per second squared and second, that gives you per second. Okay? Alright, so you got your momentum. How do you calculate the speed? You can use the Newtonian formula. So momentum is mass times speed. So solve for speed is P over M. So 2.2 times 10 to the negative 24 kilograms meters per second divided by, what's the mass of an electron? This is a good number, easy number to remember, 911. 9.11 times 10 to the negative 31 kilograms. Okay? 911. So what would that be? I have 2.2 times 10 to the negative 24 divided by 9.11 times 10 to the negative 31 kilograms. That gives me, in exponential notation, 2.42 times 10 to the 6 meters per second. Okay. Do we need to do a relativistic correction here? What is that compared to the speed of light? Divide by 3 times 10 to the 8 meters per second. That's about 0.8%. No, 0.008. So yeah, it's about 0.8% of the speed of light. So that's kind of a low speed actually. So that's going to be a negligible correction. Because what was the correction factor you're going to have to do? 1 minus v squared over c squared, right? So if you make that correction, that's 1 minus 0.008 squared. So you're not going to be off by much. But if you are close to the speed of light, you may have to do this correction factor. Okay, so instead of m, what would you have to do? You're going to have to do m naught, right, which is the reduced mass, which is 9.11 times 10 to the negative 31 over 1 minus square root of 1 minus v squared over c.
You said the relativistic comparison, like you should divide this number that we got by the speed of light?
Yes.
And then
Well, you're gonna have you're gonna have a more complicated equation, because then you're gonna say, all right, let's do this with the relativistic correction. Okay. You're gonna have to say now, you know your p, right? So you're gonna say this is going to be equal to p, and this is gonna be m naught over square root of 1 minus v squared over c squared. So that's equal to v, right? you'll have to solve for V.
That will be the formula for the comparison?
Yeah, so that's why I had you do that in MathCAD, because then it's going to be, you're going to have to do this just to solve for V. You have to solve for V first, and then you solve, and then you can plug in the numbers. Okay? In fact, let's see if we can do that in MathCAD. Is that the right formula, by the way? Let's see. Do I have it right in the numerator or the denominator? Yeah. Okay. All right. So if I were to do that in MathCAD, you're going to say that P over, what was it, M naught over square root of 1 minus V squared over C squared. The whole expression is equal to V, right? And now what I can do is solve for V, symbolic, variable, solve. And there's your expression for V. Okay? So you can say V equals that. Right, so that's going to be PC over square root of P squared plus M naught squared C squared. So let's continue. Let's try another example. Calculate the wavelength of a 0.2 kilogram ball moving at a speed of 1. I'm sorry. Huh? Oh, kinetic energy would be what? Kinetic energy would just be equal to 1/2 mv squared. Okay. Just plug in your mass and you